Hey guys, welcome to another lecture from the series Linear Algebra. In the previous class, we have understood why we need linear algebra. We need linear algebra because we cannot geometrically always look into for solutions to linear equations. Today in our lecture, there are three motives that I'm holding. First one is to understand what equations are linear, what are non-linear. Then, second thing, to understand whether a tuple, a real number, is a solution to the given linear equation. And the third thing, very important, what is a system of linear equations? What does it look like? And when is it consistent and inconsistent? So part A, linear equation. Any linear equation will look like the following. A1 x1 plus A2 x2, so on and so forth till say an xn is equal to b. So what you will see here is that you have n variables x1, x2 till xn. These are your variables. These AIs that you see, they are real numbers. They are the coefficients of this equation. They're called the coefficients of the equation, and B is also a real number, which is called the constant term. So it's the constant of the equations, okay? From here, we move on to part B to understand what is linear, what is not non-linear. So as I've mentioned, this is linear. Now, what makes it linear is the power. If you observe, the power throughout of the variables is just 1, right? So if I give you an equation 2x plus 3y equals to 4, this is a linear equation. If I give you an equation 2x squared plus 3y equals to 4, this is not linear because you can see that the power with x is 2. If I give you 2 root x plus 3y equals to 4, this also is not linear. You have root x, the power is not 1. If I give you root 2x plus 3y equals to 4 square, is this linear? Well, yes, absolutely. Because here variable power is just 1. So yes, these are linear. This is linear. So from here, you can understand which equation is linear, which is not linear. The equations wherever the power of the variable is just 1, exactly 1. So of all the variables included in there, that is linear. It doesn't matter whether coefficient is a square or not. That doesn't matter. But the variable should not be with any other power. Okay, which brings us to the motive part C. In part C, I was talking about consistency, etc. So we need to understand what are solutions to any linear equation. So suppose I give you an equation 2x plus 3y minus 4z is equal to 5. This is definitely a linear equation because the power throughout, there are 3 variables x, y, z. Power is 1. So this is a linear equation. No doubt about it. Now, if I may ask you about the solutions to this, what do we mean by a solution? A solution is a tuple, in this case, since you have x, y, z, so a 3 tuple that would satisfy this equation. Satisfying this equation means that the left-hand side will turn out to be equal to the right-hand side. That is, it will generate the value y. So what is that? X, y, z. That can generate this value 5 in this equation. Is it 1, 1, 0? Is it 0, 3, 1? Or are both of them giving you the same thing? Is it 1, 1, 1? Let's try to figure it out. So with 1, 1, 0, what's going to happen is you will get 2 plus 3 minus 0, which indeed is 5. So that means this is a solution. With 0, 3, 1, what's going to happen is you get 0 here, you get 9 here, and you get 4 here. So 9 minus 4 indeed is 5, which is same as what this equation is giving you, the right-hand side. So left-hand side turns out to be equal to the right-hand side. So therefore, this is also a solution. What if I put 1, 1, 1? So I'm going to get 2 plus 3 minus 4, which is equal to 1, and that's not equal to 5. So this is not a solution. Two of the above one are definitely solution, but the third one is not a solution. So when you assign value to the variables in the equation and your left hand side and right hand sides, they match, then that becomes a solution. In general, you will not have like just one equation and you will be looking for a solution for that. In general, you will have a system of equation. What is a system of equations? A system of linear equations will look like the following. So you have one equation, say a11 x1 plus a12 x2 plus so on and so forth. Let's say we have n variables. So a1 n xn, and that is equal to say b1. Similarly, a21 x1 plus a22 x2 plus so on and so forth. This is the second equation. So it's a2n xn. Again, of course, the variables will remain the same, x1 to xn, and say this is b2. Suppose we have m such equations. So the final equation will look like am1 x1 plus am2 x2 plus so on and so forth till amn xn is equal to bm. Again, all the AIs are coefficients. They are real numbers. All the BIs are, or BJs are constant of the equations respectively. And your x1 to xn, they are the variables. This is a system of equations. M equations, n variables. When you have certain number of equations altogether with the variables in concern, that is called a system of equation. What are we always interested in? We're interested in finding out a solution for the system of equation given to us. Now, any tuple that is a solution to a system of equation would satisfy all the equations at the same time, that is simultaneous. For example, if we have the following are solutions to this system. Now, when you want to check whether the particular point is a solution to the system again, then that means this point has to satisfy both the given equations or the entire system of equations at the same time. So if you will take 110 into consideration, the first equation will give you 2 plus 3 minus 0 equals to 5, which is absolutely giving you, which indeed will give you 5 is equal to 5. But will it satisfy the second equation? Let's see. So for the second equation, what do we have? We have minus 2 plus 1 plus 0 is equal to minus 1. Well, indeed, we are getting minus 1 equals to minus 1. So it is satisfying. This one particular point, when I plugged it in on both the equations, I am getting left-hand side is equal to the right-hand side. That means it is a solution to this system of equation. What about 634? Check absolutely on the same lines. You will get 12 plus 9 minus 16. What is that equal to? That indeed is equal to 5. So you are getting 5 is equal to 5. This is a solution to the first equation. Is it a solution to the system? For that, I need to check the, will it solve the second equation as well? So minus 12 plus 3 plus 8 equals to minus 1. Is it true? Yes, absolutely. It is giving us minus 1 equals to minus 1. Left hand side is equal to the right hand side. Or in other words, this 3 tuple is giving us the value minus 1 and the value 5 for the respective equations. That means this is also a solution. Is 031 a solution? For 031, we will have to, again, on the same lines, check the first equation. It's going to be 9 minus 4. That's equal to 5. Yes. So is it satisfying the second equation as well? Let's see. So you get 3 plus 2. That's equal to 5. It's not equal to minus 1. So it's not satisfying the second equation. Since it is not satisfying the second equation, we will say that this is not a solution to the system of equation. So system of equation is solved by a certain, n tuple, a certain tuple. That means all the equations are getting satisfied with that particular tuple. Okay. Now I used two terms, consistent and inconsistent. A system of linear equations is said to be consistent when there exists at least one solution. So which means that the given system of equations, this one, is consistent with it because it has at least one solution. We've already checked that two solutions are there. So it is consistent. What would inconsistent mean? When there are no solutions. And the moment you say no solution, that means that there is no tuple which is satisfying all the equations at the same time. That is what is consistent and inconsistent. In the next lecture, or from the next lecture onward, we will actually learn how to find out consistency and inconsistency, various ways, and how to find out the solutions. And also we will practice on many more questions. Thank you very much.